All right, let's solve this problem. So it says she spends 5/9 of vacation at grandma's. Okay, we know that that leaves 4/9 of a vacation left, right? So grandma's was 5/9, 4/9 was the rest, because total is 9/9, which is the whole vacation. So the thing is, this is a proportion of vacation. This is equivalent to some number of days, right? Grandma's some number of days, and the 4/9 left is going to be some number of days. But that number of days for the 4/9, we have to like split up again, because they say she spends 3/4 of that time. Wait, no, sorry, this wasn't at grandma's. This was at camp. Sorry about that. Ha ha ha. Okay, that's how I spend. The remaining 4/9, she spends 3/4 of it at grandma's. At grandma's. Right? Okay. Now, from that 4/9, we still have another 1/4 left, right? Because 3/4 is at grandma, and the remaining time, which is 1/4 of that 4/9, was at the beach, right, or the seashore. Thing is, it didn't tell us that it was 1/4, right? We just know by looking here. It's like, oh, 3/4 is at grandma, 1/4 is at the seashore, because that's the total of that 4/9. So this, they actually told us the number of days was 7 days, right? So we know that 7 is 1/4. So we can easily figure out how much time she spent at grandma's by just saying, oh, well, 3/4 is triple 1/4. Right, so if 3/4 is triple 1/4, then 7 times 3 is going to be 21. That's how much time she spent at grandma's, right? Because that's triple 1/4 is 3/4, so triple the number of days gives us 21. It's like ratios, right? What did we do to go from here to there? Oh, we multiplied by 3. So I'm going to do the same thing to this side of the ratio, multiply by 3. So what's missing now is the number of days at camp. And so, like, there's a bunch of different ways we could figure this out. We can figure out this total number of days and go, oh, that's 4/9, so let's make it 5/9. Or we can be like, oh, you know what, 4/9, if I add one more ninth, then I end up with 5/9. So then I can just do some simple math to find out what 1/9 is, add it to 4/9, and then I know what 5/9 is, right? That's how we add fractions. 4/9 plus 1/9 is 5/9. So we actually do know what 4/9 is in terms of the real numbers. It's the total of these two. So that 4/9 total is 28 days. So 28 days is the 4/9 portion of the total, right? It's the 4/9 of the whole thing. So if we were like, what's 1/9? Well, 1/9 is like 1/4 of 4/9. And so we say, okay, well, what's 1/4 of 28? Just going to divide that by 4, and we see, oh, 28 divided by 4, why, that's 7 again. That's actually the whole time she's at the seashore was actually 1/9 of the entire vacation. Didn't know that at the time. We know now. So now if we say, okay, well, 4/9 plus 5/9, I'm sorry, 4/9 plus 1/9 is equal to 5/9. Then doing that in days, 4/9 was the total. Right, so 21 plus 7. So that's 21 plus 7 is going to be 28. And then 1/9 we just figured out was 7, so we just add 7 to that. And that tells us that, that tells us that 5/9 is equivalent to this total, which is 35. So we just found how many days is represented as 5/9 of the whole, which is what the last number we're looking for here is 35. Now, if we total all three numbers, we get the entire vacation. The total, right? It would actually be the whole. If we were to add these up, we get the whole amount. I can show you a more advanced version using some algebra if you wish, but it's a little bit more grade 8, 9-ish kind of style of solving. But here, the entire vacation would be 35 days plus 21 days plus 7 days, which is going to be equal to a total of, let's stack them. It's easier to add when you stack. There we go. Columns are our friend. 5 plus 1 is 6, plus 7 is 13. Carry the 1, and then we have 3 plus 1 plus 2 is 6. So 63 days. And like all good word problems, we should answer with a full sentence. So we say, therefore, she had 63 days of vacation. Okay, so hopefully that was clear and easy to follow. And if there's a specific topic that is in that section of the book that you were practicing, like that is reflective of this, or maybe suggests you should solve in a different way, then I could always try and provide a different solution another time. That's it.